Hi, good day, everyone. Allow me to introduce myself. I'm Dr. Jonathan Tailar from Technological Institute of the Philippines. And today I'm going to talk about application of AI in data analytics, enhancing insights and efficiency. Here are the outline of my presentation: introduction to AI and data analytics. I'm going to talk about automated data processing, predictive analytics, natural language processing, pattern recognition, cluster analysis, recommendation system, automated decision making, continuous learning and adaptation, data security and fraud detection, automation of data insights, and future trends and developments of AI and data analytics. Okay, let's start with the definition of AI and data analytics. Well, for a start, artificial intelligence, it's a branch of computer science, and it aims to create intelligent systems capable of performing tasks that typically require human intelligence. So this field focuses on developing algorithms and technologies that enable machines to mimic various cognitive functions such as learning, problem solving, and decision making. In terms of learning, AI are designed to learn from data and improve their performance over time without being explicitly programmed. So this process is known as machine learning. So it involves the development of different algorithms, no, which enables computer to identify patterns in data, make predictions, and adapt to new situations based on past experiences. In terms of problem solving, AI are capable of solving complex problems by analyzing information, reasoning through possible solutions, and making decisions based on available data. And this problem solving ability is often achieved through many techniques. Now, for example, search algorithms, optimization methods, and logical reasoning systems. Now, AI can also handle decision making by evaluating various factors. For instance, weighing potential outcomes, selecting the most appropriate course of action. And these decisions may be based on predefined rules. It can also be based on statistical probabilities or learned patterns from data. Decision-making AI can range from simple classification tasks to more complex decision-making processes in strategic planning, resource allocation, and autonomous system. So basically, on the other hand, the process of examining, transforming, and modeling data to extract meaningful insights, draw conclusion, identify patterns, and support decision making. This is what data analytics is all about. It involves various techniques and tools for collecting, processing, and analyzing large volumes of data from different sources. Now, in terms of integrating AI in data analytics, it offers a variety of several advantages, which enhance efficiency, enabled advanced pattern recognition, facilitate predictive modeling, support adaptive learning, and bolster data security. So AI can handle can automate repetitive tasks, which involve uh, in instances such as processing of data, data cleansing or data cleaning, analysis, leading to significant time savings and improve operational efficiency. Now, by automating routine tasks, AI enables data analysts and scientists to focus on higher value activities such as interpreting results, generating insights, and making strategic decisions based on data-driven recommendations. AI algorithms can optimize resource allocation. They can also streamline workflows and identify areas for process improvement, no? Thereby enhancing overall efficiency in data analytics processes. AI can also recognize patterns, particularly machine algorithms. They excel at identifying complex patterns and relationships within large data sets, no, that may not be readily apparent to human analysts. So by leveraging AI for pattern recognition, organizations now can uncover valuable insights. They can also detect anomalies and discover hidden correlations in their data, which can inform strategic making or strategic decision making and drive innovation. AI powered pattern recognition can be applied across different domains, no, including uh, customer behavior analysis, fraud detection, predictive maintenance, and market trend identification, among others. In terms of predictive modeling, AI enables the development of sophisticated predictive models, no, that leverage historical data in order to forecast outcomes, trends, and events, no, with a high degree of accuracy. If you integrate AI into data analytics, organizations can build predictive models that can anticipate customer preferences, um, what else? Uh, Market demand, equipment failures, and other critical factors, no, which allows them to perhaps proactively address potential challenges and capitalize on emerging opportunities. Predictive modeling powered by AI helps organization optimize resource allocation. They can also mitigate risk, and they improve their decision making by providing actionable insights based on predictive analytics. In terms of adaptive learning, AI data analytics systems can continuously learn and adapt to evolving data patterns and trends, enabling them to improve performance over time and deliver more accurate and relevant insights. And through techniques, no, for instance, such as reinforcement learning and deep learning, AI algorithms can adapt their behavior based on feedback from new data or user interactions and changing business requirements. The capabilities of adaptive learning enhance the agility and responsiveness of data analytics solutions, which allows organization to stay ahead of competition. They can also mitigate risks and seize opportunities in dynamic environments. AI data analytics can enhance data security, you know, by identifying and mitigating potential threats, detecting anomalous behavior, predicting cyber attacks before they happen. AI powered security solutions can analyze large amounts of data in real time to identify suspicious patterns, unauthorized access attempts, and other security risks, you know, thereby enhancing the threat detection and incident response capabilities. If you integrate AI into data analytics workflows, organizations can strengthen their cybersecurity posture. They can also protect sensitive data assets and ensure compliance with regulatory requirements, no? Ultimately safeguarding their reputation and maintaining customer trust. So here are some overview of the key applications of data analytics or AI in data analytics. So we'll talk about them one by one, including automated data processing, predictive analytics, NLP, pattern recognition, cluster analysis, recommendation systems, automated decision making, continuous learning and adaptation, data security and fraud detection, automation of data insights. Now, we'll talk about them one by one. Let's first talk about automated data processing. So what's automated data processing? Um, this processing is a type of processing which refers to the use of algorithms and different technologies in order to streamline and expedite various stages of data processing pipeline, from data ingestion and cleaning to transformation and analysis. So this automation is probably um, particularly valuable in handling large volumes of data. They handle it efficiently and accurately. And we're going to talk about, uh, for instance, data cleaning. For example, data cleaning with AI algorithms. No, we call it data cleansing. It's the process of uh, when you want to identify and correct errors in your data, and when you see inconsistencies, when you see missing values in data sets, so that your data becomes reliable, and it becomes it will have quality on the data. AI algorithms play a crucial role in automating this process, via machine learning and natural language processing techniques, for instance, in order to detect and rectify data anomalies. And some common AI approaches to data cleaning include anomaly detection, imputation, normalization, and standardization, and that includes text processing. For automated data transformation, this is where we convert our raw data into a format suitable for analysis or visualization or other downstream tasks. AI-driven automation simplify and accelerates this process by automatically performing tasks. For example, feature engineering, when you want to reduce the dimension of your data sets, data aggregation. And some of the example of this are feature engineering, dimensionality reduction, data aggregation, and summarization. Now, there are many benefits of AI in data processing. If you integrate AI into data processing, there are several benefits, and that includes efficiency, which means the automation accelerate the data processing tasks, and thereby, of course, reducing manual effort and time to insight. And by automating repetitive tasks, organizations now can improve productivity and focus human resources on higher value activities. Another one is accuracy. AI algorithms can handle large data sets with complex structures and noisy data more effectively than manual methods. No? It leads to improved data quality and reliability, because automated data processing reduces the risk of human errors and biases inherent in manual data manipulation. It also gives us scalability. No, when you say scalability, uh, AI driven data processing solutions are highly scalable and adaptable to changing data volumes, velocity, and variety. That is the characteristics of a big data. No? The term, the triple B, what we call triple B, volume, velocity, and variety. Whether processing small-scale data sets or big data streams, AI can handle dynamically to meet computational demands and performance requirements. Another one is if you leverage advanced analytics and machine learning capabilities, AI enhances the depth and breadth of insights derived from data processing. Automated data processing enables organizations to, of course, uncover hidden patterns, trends, correlations that drive informed decision making and innovation. Now, another key application of AI in data analytics is the natural language processing. I'm sure you are familiar with this. No? It's a branch of AI, and it focuses on enabling computers to understand, interpret, and generate human language in a manner that is both meaningful and contextually relevant. No? Text mining is one of that. Sometimes it is referred to as text analytics, and it is a specific application of natural language processing, which involves extracting useful information and insights from unstructured text data. Now, this is a technique to pre-process the raw text data, and it involves the concept of tokenization, which means you break text into words or sentences. No? Another way is to stem, or we call it stemming, which is to reduce the words to their root form. And there is also a term called lemmatization, which allows us to reduce words to their dictionary form. So these steps helps in standardizing and preparing text data for further analysis. Another one is the information extraction. Natural language processing enables the extraction of structured information from unstructured text data. And this includes tasks such as name entity recognition, no, entity linking, relation extraction. Another one is, another application of that is sentiment analysis. What do we mean by sentiment analysis? You may see it from time to time, no? Uh, reading some articles in the online platforms, no? And then afterwards there are some questions for you to answer, or there's something like a button to like. Now, NLP techniques are used to analyze the sentiments expressed in text data. For example, whether a piece of text is positive, could be negative or neutral. Uh, are you happy with what you saw, what you read? You in Netflix, we saw it. If you are happy with this, if you like this movie or TV series, sentiment analysis is widely used in customer feedback analysis, social media monitoring, and particularly market research. Another application of NLP is topic modeling. No? It can automatically identify topics or themes which are present in a collection of documents. No? There are techniques such as LDA, if you're familiar with that, latent derelict allocation. And there is also a technique called non-negative matrix factorization. They are commonly used for topic modeling in text mining applications. Of course, we do have some applications such as text classification. No? And NLP enables automated classification of text documents into predefined categories or labels. And this includes tasks, for example, spam detection in an email, no? Sentiment classification, and topic categorization. There are many types of applications of NLP, and we cannot talk about all of that. But we will give some examples. No? For example, um, if you browse the internet, NLP now is being, the web now is being powered by NLP, or natural language processing, wherein the search engines has the capability to retrieve relevant information from a very vast amounts of text data available on the web or within an organizational's internal documents. There are also what we call question answering systems. So you may be familiar with this NLP-based question answering system. They can understand and respond to user queries in natural language. For example, virtual assistants like Siri, Alexa, or Google Assistant. In terms of language translation, I'm sure all of you may have experience to use Google Translate. No? This enables machine translation system to translate text from one language to another. No? It facilitates, of course, communication across linguistic barriers. Another one is text summarization, where NLP can automatically generate concise summaries of long documents of articles, helping users to quickly grasp the main points without reading the entire text. And then, of course, the sentiment analysis that I mentioned a while ago. It's used for analyzing sentiments in social media posts, customer views, and other forms of user-generated content to understand the public opinion and sentiment trends. Now, in NLP, there are also some applications that are already placed. No, it is not there to replace humans, but basically uh, to complement humans. No, for example, chatbots and AI assistants. No, these are applications that basically interact with users in natural language. They provide information, they answer questions, they also perform tasks or simulate human conversation. These chatbots and AI assistants understand user queries. They also extract relevant information, and they generate appropriate responses in natural language. No, they are used in various domains, no, including customer service, e-commerce, healthcare, and education. No? And they provide personalized assistance and automate routine tasks. There are also some advanced chatbots, no? And basically they leverage machine learning and NLP techniques to improve their conversational capabilities over time, learning from user interactions and feedback. No? Yung what we call the generative AI nowadays, which allows the machine to give information, a lot of information, like the uh, uh, chat GPT and sort of that. A common technique in artificial intelligence is what we call cluster analysis. No? This is used for segmentation and probably perhaps used for many purposes, especially in the business management transactions. No? Cluster AI enables segmentation, for example, of customer profiling. So basically, it provides personalized marketing strategies for specific customer segments with relevant messages, products, and experience. No, if you use AI in particularly in marketing, no? You leverage it for customer segmentation and personalize your marketing. Businesses can enhance customer engagement. It increase conversion rates and drive long-term customer loyalty and satisfaction. And nowadays, many businesses are incorporating AI, particularly cluster analysis, in providing insights with their customers' profiling and segmentations. Another one is, of course, you may have been using it for quite some time, is the recommendation systems. No, in AI, these are algorithms and techniques which is used to suggest items or contents to users, no, based on their preferences, interests, and past behaviors. No? There are many approaches to building recommendation systems, and that includes collaborative filtering, content-based filtering, and personalized recommendations. No? Collaborative filtering, it is about recommending items to users based on the preferences and behavior of similar users. No? And it leverages the wisdom of the crowd by identifying patterns and similarities among users' interactions with items. Uh, an example of that is when you buy something from Shopee or Lazada, you get to be advertised with similar items, or what are the other customers buying. You have some recommendations of that. So those are AI-enabled algorithms. Another one is content-based filtering, which allows us to recommend items based on the characteristics or attributes of the items themselves. It analyzes item features, for example, text descriptions, metadata, or features extracted from content to make recommendations. When you buy this product, what are the usual things that other customers are buying with the same characteristics of the item? And then we have the personalized recommendations. These are combination of collaborative and content-based filtering techniques, no? Which is used to provide personalized suggestions to users. And these systems take into account both user preferences and item attributes to generate recommendations tailored to each users. In AI, continuous learning and adaptations are very fundamental aspects, no? Particularly in the context of adaptive models and reinforcement learning. Adaptive models are machine learning models that have the capability to continuously learn and evolve over time. And these models can adapt to changes in the data distribution, environment dynamics, or user preferences without the need for manual intervention. On the other hand, if you heard about reinforcement learning, these type of machine learning models, they have the capability to continuously learn, um, where an agent learns to interact, with an environment to maximize cumulative rewards or achieve a specific goal. It learns through trial and error, and it receives feedback in the form of rewards or penalties, based on its actions. So, what are the importance of continuous learning? Of course, it enables AI systems to basically adapt to changes, in the environment, also in user preferences or data distribution. And this adaptability is crucial for maintaining performance and relevance in dynamic and evolving scenarios. Um, AI is also applied in data security and fraud detection. In critical aspects of AI application, especially in the domains where sensitive information are involved. For example, finance, healthcare, e-commerce. Basically, anomaly detection, behavioral analysis are key techniques, which are used to enhance data security and detect fraudulent activities. AI is used for fraud detection. We use to identify fraudulent transaction activities, in finance, or some sort of behavioral patterns in financial transactions, credit card usage, insurance claims, online transactions. Anomaly detection is also employed to detect abnormal network traffic, for example, in computer networks, system activities, user behaviors that may indicate like a cyber attack or security breach in computer networks or IT systems. It is also used nowadays for health monitoring. Anomaly detection techniques are applied in healthcare to detect abnormal physiological signals, patient vitals information, or disease symptoms, aiding in the early detection of health issues or medical emergencies. Basically, behavioral analysis, it involves monitoring and analyzing patterns of behavior to identify suspicious or malicious activities. It focuses on understanding how users interact with systems, applications, or networks, and detecting deviations from the expected behavior. Some of the examples of behavioral analysis is when you use it for, like for example, authentication and access control of detection of suspicious login attempts or password guessing attacks or unauthorized access based on user behavior patterns. It helps in preventing fraud by identifying unusual transaction patterns, or identify theft based on user behavior in financial transactions or online activities. It also detects insider threats by monitoring employee activities, access privileges, and data usage to identify suspicious behavior or policy violations, within organizations. So basically, by leveraging these methods, organizations can identify and mitigate security threats. They protect sensitive information and safeguard against financial losses or reputational damage resulting from fraudulent behavior or security breaches. Additionally, it implements robust data security measures, for example, encryption, access control, authentication, auditing, and it further enhances the defenses against evolving cyber threats and ensures the integrity and confidentiality of data assets. Automation in AI, particularly of data insights. No? It happens when you use AI as a leverage tool for automating, perhaps doing some tasks that are have to be done repetitively. No? For example, it allows AI allows automated reporting, cognitive automation, streamlined decision making. No, so basically, when you do automated reporting, it involves the use of AI and data analytics tools to generate reports automatically, no, from raw data without the need for manual intervention. And these reports can include visualizations. It can include summaries and key insights derived from the data. On the other hand, cognitive automation involves the use of AI technologies such as natural language processing, machine learning, cognitive computing to automate cognitive tasks that typically require human intelligence. No, for example, understanding, natural language reasoning, and decision making. Automation of data insights streamlines decision-making processes by providing timely, relevant, and actionable insights, no, to decision makers by automating routine tasks and analysis. Organizations, no, can now accelerate decision-making cycles, and they can respond quickly to changing conditions. Now, the field of AI is rapidly evolving, and several emerging trends and developments are shaping its future. No? And I'm going to give you some examples of emerging trends in AI, particularly, for example, as we can see nowadays, no, AI-driven automation is revolutionizing industries, no, by using automating repetitive tasks, streamlining workflows, optimizing processes. No? Now we have RPAs, or robotic process automation. It is coupled with AI technologies like machine learning and natural language processing, wherein it enables organizations to automate a wide range of business processes, no? From data entry and document processing to customer service and IT operations. Another sample is the explainable AI, or they call it the XAI. It focuses on making AI models and algorithms more transparent and interpretable and understandable to humans. No? As AI systems become increasingly complex and pervasive, no, of course, there's a growing need to understand how these systems arrive at their decisions and predictions. No? And XAI techniques aim to provide insights into AI model behavior. They foster trust and facilitate human AI collaboration in critical domains, no? For instance, in healthcare, finance, and criminal justice. Another example is edge AI. You know, if you have heard about edge computing, you know, it involves deploying AI algorithm and models directly on the edge devices. You know? For example, smartphones, IoT or Internet of Things sensors, edge servers. They perform inference and decision making locally. And by processing data closer to the source, Edge AI enables real-time analytics, low latency responses, and efficient use of bandwidth, making it well suited for applications in Internet of Things, smart cities, autonomous vehicles, and industrial automation. AI now is transforming healthcare and life sciences by accelerating drug discovery, improving diagnostics, what else? Personalizing patient care. No? And there are many deep learning algorithms that can analyze medical imaging data, genomics data, electronic health records, wearable sensor data, no? To assist clinicians to diagnose, uh, doing some treatment planning and disease monitoring. And there are also AI-driven drug discovery platforms, no, which can leverage machine learning to identify novel drug candidates. They can also predict target interactions and optimize drug development pipelines. Now, advancement in natural language processing nowadays are enabling AI systems to understand, generate, and interact with human language more effectively. No? So we have some examples of that, like transformer-based architecture, like BERT or BERT, if you are familiar with that, with the bidirectional encoder representations from transformers, and popular GPT or chat GPT as we call it. No, the GPT means generative pre-trained transformer. No, they have significantly improved the language understanding and generation capabilities, which leads to breakthrough in chatbots, virtual assistants, language translations, and sentiment analysis. Most probably nowadays, AI-driven automation is transforming our industries. No, not only that, we have plenty of other examples. No, but more importantly, as AI technologies become increasingly pervasive, in society, there is growing awareness of ethical, social, and legal implications of AI systems. Future trends in AI development may focus on integrating ethical principles, no? And that is the suggestions of many researchers. If people will try to develop more AI technology, they have to focus on integrating ethical principles, fairness, uh, mitigating biases, no? And accountability mechanisms into AI systems so that they can ensure that these AI technologies are aligned with our societal values. No, they should respect human rights, and of course minimize unattended consequences. And addressing the challenges and ethical considerations associated with AI, it requires a multidisciplinary approach. No, it involves collaboration between different researchers, policymakers, industry stakeholders, civil society, and every one of us. No? We should promote transparency, fairness, accountability, privacy, and human-centric design principles. And we can harness the transformative potential of AI, while minimizing risks and maximizing the societal benefits. The transformative power of AI extends, across industries and domains. It revolutionizes how business operates today and how societies functions nowadays, how individuals interact with technology. But if we try to harness the capabilities of AI to automate tasks, derive insights, personalize experience, maybe we can drive innovation, or we can unlock new opportunities and address complex challenges and problems and create a brighter future for humanity. But we have to do it ethically. Remember, there is nothing to fear with AI. AI will never replace humans, but rather, I believe that AI will replace humans that does not know how to use AI. So, in behalf of my department, the computer engineering of the TIP Quezon City, I would like to thank you for your attention for this talk.